Continue section P.4 on linear modeling. In the next couple of problems that we'll look at, we're going to see that sometimes instead of giving us a table of values with our data, they just give us a description. When that happens, we sometimes can identify the slope and the y-intercept just based on the description. And sometimes it's more easy to organize the information into a table of values. And then we can kind of proceed as before by making our own table of values first. In our first example, it says shipping costs depend on the weight of the item shipped. Your company is shipping potatoes in wooden crates that weigh 8 pounds. Bags of potatoes weighing 10 pounds per bag are put into these crates. Write a function that gives the total weight W of a crate containing B bags of potatoes using function notation and our variables. As I look at this description, I can actually probably find the slope and the y-intercept just based on the description. If you think of the slope as the rate of change, what's going to happen every time you put a bag of potatoes in the crate? Well, every bag weighs 10 pounds, and so the weight's going to go up by 10 pounds each time. My rate of change is 10 pounds per bag. And so I think I'm going to have a slope of 10. B, the y-intercept, is the starting value. In this case, how much weight do you have when there's 0 bags of potatoes in the crate? Well, at that point, you only have the weight of the crate itself, which was the 8 pounds. So B is going to be 8. Looking at that, I can already see that y equals 10x plus 8 is going to be my equation for my line. I want to give you one alternative way of looking at this, and then we'll change to the variables for the problem. If identifying that information from the description is not as easy for you, another option is to create your own table of values. The independent variable in this case is the B, the bags of potatoes. And then the dependent variable is the weight that results from however many bags you're going to put in the crate. We can make our own table by just saying, well, with 0 bags, the crate itself just weighs 8 pounds. With 1 bag, I'd have 10 pounds of potatoes plus 8 pounds of crate. That would be 18. And you could keep going if you wanted to. With 2 bags, that would be 20 pounds of potatoes plus 8 for the crate. It's 28 bags and so on. Once you have a table of values, you can use our usual methods for finding the equation of a line. Find M, find B. To find M, I will take the difference in the y values, 8 minus 18, over 0 minus 1, which gives me negative 10 divided by negative 1, which is a slope of 10. Notice exactly what we predicted from the language. And as far as the find B, the y-intercept is really given here. At 0 bags, we had 8 pounds. And so that way, we come up with the same final result. Y equals mx plus b. Y equals 10x plus 8. Either way, whichever way is easier for you to think about it is just fine, but they're both good skills to have. All right, let's finish this part of it by going ahead and changing to the variables. In this case, our B value is the X, and the W is the Y. So our final answer, instead of Y, I'd have W, the weight, and instead of X, I'd have B for the number of bags, like so. And function notation then, W depends on B, or W is a function of B, is equal to 10B plus 8. Okay, the second part of this problem, explaining the slope. Slope was 10. And in this case, the wording that you need is literally given to you in the problem. It's the rate of change of weight with respect to bags. The weight increases by 10 pounds per bag of potatoes. You can really almost see that right up here. The weight is 10 pounds per bag. And so just adding a little bit more language around that generated our slope statement in this particular case. By the way, one other mention I would just make here is, notice that I do always include my units and my measurements when I do describe my slope and my y-intercept. All right, in part C, we want the meaning of the w-intercept. Since the w and the y are the same, I can just go ahead and grab that y-intercept. W-intercept is 8. And that's what happens at the starting point. When there are no bags of potatoes, the weight is 8 pounds. Okay, oops, sorry, next page, a few more problems on the same thing. I'm just going to go ahead and jot down our equation here so we can keep on using it more easily. The weight, depending on the bag of potatoes, was 10B plus 8. All right, we want W of 15. So basically we're just plugging in 15 for the B. And that's what, 150, 158? So 15 is B, 15 bags of potatoes, result in a weight of 158 pounds. And then, finally, find B when W of B equals 128. So the 128 goes on this side instead of the W of B. And I set that equal to 10B plus 8. Solving that equation, I'm going to subtract the 8. So 120 is equal to 10B. And then just dividing by the 10, B is going to be 12. So with 12 bags of potatoes, my shipping weight will be 128 pounds. And by the way, notice I'm kind of using a slightly different form of the sentence each time. I just want to show you there's different ways to write this. There's no single right way all the time. But my main thing when you're doing these problems, for example, on a test or something and looking to earn all the points you can, of course, you just want to make sure that you're giving me a full and complete description so that if I looked at your answer without ever having seen the data table, read the problem, the answer would make sense. I could read that sentence and understand what it means independently. All right, let's do one more problem in this sort of descriptive vein. A scuba diver experiences more pressure as he or she descends deeper under the surface of the water. One way that we measure pressure is in units called PSI, or pounds per square inch. At the surface of the water, the pressure just because of the atmosphere is 14.7 psi. If you're at sea level, just walking around on the land at sea level, you're going to have 14.7 psi of pressure. After descending for 20 feet, the pressure on the diver has increased to 23.4 pounds per square inch. Under the assumption that pressure increases linearly with depth, find a function for the pressure P as a function for the depth D, using function notation. This time, they really didn't give me any rate of change anywhere in this problem. I can't find it at all. So I think creating my own table of values is really the way to go. The function is pressure as a function of depth. So the input is the depth, D, and the output is the pressure, P. Going back into the water, excuse me, we're not going in the water, we're going into the problem. Going back into the problem. At the surface of the water, that would be a depth of 0. The pressure is 14.7 pounds per square inch. Then at a depth of 20 feet, diver's gone down 20 feet, the pressure has become 23.4 pounds per square inch. There's no additional information in the problem, but that's really enough. If I've got 2 points, I've got enough to find a slope. And actually, I can find a Y-intercept, although nicely, this one's kind of given. So let's do that. Find slope. Find Y-intercept. Using our usual slope formula, y2 minus y1, 14.7 minus 23.4, over x2 minus x1, 0 minus 20. And let's see, I'm going to grab a calculator and get those values if you want to go ahead and do the same. I've got negative 8.7 divided by negative 20 gives me 0.435 for my slope. And as far as the Y-intercept, again, we actually know what happens when the depth is 0. So really, I don't have to do any calculations. I already know in this case. B is 14.7. So my line, y equals 0.435x plus 14.7. Now I'm just going to convert that to the variables that we're using. My x value is actually the depth, and my y value is the pressure. So I would rather write my equation as, not y, but p for pressure, as a function of depth is 0.435 times d plus 14.7. All right, on the next page, we'll answer a few questions about that equation. So I'm just going to rewrite that for us at the top of the page. Pressure as a function of depth. Like so. There we go. All right, we want the meaning of the slope in the context of our situation. We know our slope is 0.435. And that's going to be the rate of change. Now, it's the pressure that's changing with respect to depth. So pressure had units of PSI, pounds per square inch. And I'm going to say the pressure is increasing for a positive slope. By that much, 0.435 in units of pounds per square inch, PSI. And that's for a change of 1 in the depth. That's when the diver descends by 1 foot. So, per foot, the diver descends. Again, notice that that statement can be read independently of the problem, and it makes sense. Even if people didn't see the original problem, that sentence is sensible. It would make sense to somebody. All right, the P-Intercept. This is the one that I can actually grab right out of the table, but I'll remind you also that if I want the P-Intercept, that means the opposite variable, d is equal to 0. So I actually could get it this way, by plugging 0 into my equation for d. And that gives me that 14.7 that I saw here as the Y-intercept or P-intercept also. When depth is 0 feet, so at the surface of the water, pressure is 14.7 psi. This might be a good time to go back and just kind of get that bigger view again. When you're talking about slope, remember that you're always talking about a rate of change. Something is increasing or decreasing. When you're talking about an intercept or a specific value of the function, now you're just talking about at a particular point, in this case a particular depth, this is what the pressure is. All right, in D, we want to find the pressure when the depth is 100 feet. So that means we're going to put in D equals 100. I can even write that as P of 100. And then plug the 100 in for the D value. And let's see. I'm getting 58.2 for that. And since that's pressure, the units would be pounds per square inch. All right, and then the last question about this particular example, we'd like to find the depth at which the pressure is 100 psi. So this time the 100 goes in on the P side of the equation. 100 equals 0.435 times that unknown depth plus 14.7. And then we'll just solve that equation for D. Dividing by the 0.435 to finish it up. Gives me 196.1 approximately. So we're finding a depth, that would be in feet. All right, so we'll stop this video right here, and then we'll finish up the section in our next video.